What are the differences between rote counting and resultative counting? An adult, a father, for example, when he says that his son knows how to count, in reality, what he is saying is only that he knows how to recite a series of numbers. For example, he can say, "My son knows how to count to 20." But what he is saying is that he knows how to recite the names of the numbers from 1 to 20. We as teachers know that there is a lot more behind saying that a person or a child knows how to count. There are a lot more things. It is for this reason that we distinguish between the two types of counting, rote counting and resultative counting. Rote counting is where a series of words is associated with each number. But we have another type of counting, which is related to saying how many objects there are within a specific set of objects that we present to a child. Right? So we have these types of counting, and we will comment on some characteristics. Children, when they learn this recital of words, sometimes they don't distinguish between where one word starts and another ends, right? And this is the reason that we always propose a task to do with the children, one that has two movements, and to associate a movement with each word. 1, 2, 3, 4, because this helps us so that the child understands when one word corresponds to one object and when another word corresponds to another object. After having learned this recital, which also has its problems, which we'll comment on later, but after having learned these words, that is, we're familiar with rote counting, we must relate this to a series of objects, and this then presents some very specific difficulties. The child must coordinate the recital with the objects, and will have to do so without repeating any of the objects that have been counted or omitting any. This is why we also practice, after having done some rote counting, some specific skills applicable to resultative counting. Okay? So we say that a child knows how to count to 20 if we can give them a group of objects that has up to 20 objects, and they can always tell me how many objects there are, and this includes knowing how to recite and additionally knowing how to coordinate it with the objects. Why is it that students first learn to say the previous number before learning to count backwards? Very good. What we noted a moment ago was that rote counting has specific stages and specific difficulties, which often we are not aware of. It is something we do not consider when we think about it. The first stage of rote counting is when I ask the child to count forwards by 1. And the child can count from 1 to 10, from 1 to 20, let's say up to the number they can count to at that moment. But later, there is a task that is a little more difficult, which is the following. When I ask a child to tell me the number after 7, what I am asking is that without having to start from 1 and go forward, they know that in this recital, 8 always comes after 7. Okay? This is not a fundamental question, and we consider this very clearly when we think about the alphabet. If I am asked what letter follows S, then sometimes I do not have to refer to the alphabet from where I say it, but in order to say the letter after S, I have to say O-P-Q-R-S-T. There is a moment with numbers when I have to say the following without having to run through the previous numbers. And this is a task which has a higher degree of cognitive difficulty than simply counting forwards. Therefore, we have as a first task, counting forwards from 1. As the second task, say the number which follows a given number. And now, from this moment, I'm able to count forwards starting from any number. Note that this will be a fundamental, basic skill to build upon later. That is, we must pay attention to this skill. Counting forwards goes in this order. Yeah? The problem is that in order to count backwards, the order is not the same. In order to count backwards, the first thing that we must do is say the preceding number. And it is in this manner that if I want to count backwards from 13, then I have to know what is prior to 13, what is prior to 12, what is prior to 11, and so on successively. Therefore, it is a prerequisite to be able to say the number prior to any number. Which is not easy. When I ask a small child to tell me the number prior to 13, many times they have to count forwards. And when they get to 13, remember to store in their memory the number that they say immediately before it. Okay? If this is not done automatically, later it's hard to count backwards because you cannot do it many times because you forget. Therefore, the first stage of counting backwards is to practice saying the number prior to another number, and then indeed count backwards, starting from any number, which is a prerequisite, a basic skill for performing elementary subtraction. Therefore, with respect to rote counting, and we are talking solely about counting one by one, we already have some specific difficulties. To this, we also add that we have to work at counting, for example, by 10, forwards or backwards. Therefore, the idea is so, we can say, immediate, that rote counting is much easier than resultative. And we can qualify this by noting that when we start to break it down, we see that there are many things in between. What are the benefits of grouping the objects that we want to count in tens? When we have many objects, for example, when we have a box full of counting blocks and we throw them on a table for the children and ask them how many there are, a good way is to group them. One, because that way we can share the task and do it cooperatively. If we all say, we'll put them into small groups, first we make the groups and then we count, it goes very well. The groups, given that our system is decimal, that is, our manner of expressing the numbers is decimal, the best way to do it is to group them into groups of 10, little groups of 10. So each child makes their groups of 10, and when all the objects are in groups of 10, we look to see how many remain. And if, for example, there were 53 objects on the table, that means that there are 5 groups of 10 and 3 loose ones. So, the child can quickly use rote counting of the groups of 10 to count without, let's say, an efficient methodology, and point out each group, not each object, and say 10, 20, 30, 40, 50, and these 3, 53. Therefore, the incentive to group is really a motivation that is task-dependent. If we were very quick at counting by eights, then we would group by 8, but we're very quick at counting by tens. And the other question is when we count many objects, sometimes we need to recount to see whether we made an error. And what happens is that if they are already grouped, then it is easier to check to see if it was done well, because really, it consists of checking that I have made groups of 10 and not 9 or 11. Okay? It is also possible that some students group by 5, and later, using each 2 groups of 5 as if they were hands. They make groups of 5, but later they see that 2 groups of 5 are 10, 20, 30, which is the same. What is the information that we lose when we ask for written counting responses? Counting, we should always assess orally. It is imperative. We know that this is very complex, more so in a class when we have almost 25 students. Assessing everyone's ability to count orally, but, well, we must be very conscious of what the interferences are when, in order to save time organizing, let's say, the task with many students in a more efficient manner, we substitute an oral task for a written task. The first issue is that we have an interference of having to write. If a child does not know how to write a number, That is something I have to identify separate to whether or not they know how to count. It may be that they know how to count up to 27 objects perfectly, but they don't know how, for example, how to write the number 27, or how to write the 7 or the 2, although they say 27, or various difficulties related to writing. It is not something that need not be evaluated, but we must separate the variables used to correctly diagnose the status of each student. So, we have an interference problem if we request it in writing, then we also have the symbols which intervene. But additionally, we are not performing the same task. Even if it is rote counting, how is it that we could request rote counting from a child in writing? Write all the numbers from 20 to 30, or continue this series, and we put 20, 21, 22, and the student continues. It is clear that rote counting is an oral task, but a child might have learned perfectly that in writing, you answer by first putting 2, 2, 2, 2, 2, and then 1, 2, 3, 4, 5 as the second digit, but not understand that this is a number that is called 21. Instead, they learn survival tricks early on because they know what it is that we are asking them to solve. So, the problem is that it is obscured. The actual knowledge remains hidden if the child knows how to perform rote counting and also resultative counting if we only do it exclusively on the written level. We must combine it with oral tasks in order to be able to properly assess the students.